Okay, on 2.6, we're going to do just types of solving other types of equations that will lead to using um, quadratic things that we've already talked about. So let's look at our first one. Now this is some that we have looked like we've seen before, and when we solve it, we'll solve it like we've done before. So this is going to be an equation that has some rational expressions, and we treat them like fractions, and we get rid of all the denominators by multiplying by the least common denominator. In this case, the least common denominator is x minus 2. On the right-hand side, it left-hand side eliminates the fraction. Right-hand side, we get 2 plus 2 times x minus 2. Okay? When we go through solving this, we get 2x minus 4, which is negative 2 plus 2x. Subtract 2x to the other side, I get negative x equals negative 2, or x equals 2. Now, in this section, it's important that we check our answers. If you look here, since we have x equal to 2, if we plug that in right here or right here, you'll see we'll have 0 in the denominator. And we cannot have 0 in the denominator. That's an undefined expression. So, in this section, it's very important to check our answers. So when we check this, we see that it doesn't work. So our solution is no solution. Okay? Because it doesn't work. Let's do another one. 3x minus 1 over 3 let's do minus 2x over x minus 1 equals x. Now in this case, the common denominator is going to be 3 times x minus 1. On the right hand side, we end up with 3x times x minus 1. 3's cancel on the first one, so I'll have x minus 1 times 3x minus 1. Then the x minus 1's cancel, and I end up with 3 times 2x, or 6x. So I have 3x squared minus x minus 3x plus 1 minus 6x equals 3x squared minus 3x. Now you can see that 3x squares will cancel, and so will the negative 3x's. So I end up with negative 7x plus 1 equals 0. So we have negative 7x equals negative 1, or x equals 1/7. So you can check this one just like the other one, but when you plug that in here, that's the only place where it go in. It's not going to cause 0. So this is our only solution, as x equal to 1/7. Okay, now this one I just did, you see that I ended up with some x squared terms, but they disappeared. This next one, we're going to end up with x squared terms, and they're not going to disappear. So let's do 3x plus 2 divided by x minus 2 plus 1 over x equals negative 2 over x squared minus 2x. Now, over there on the left-hand side, just so you can see it a little bit easier, that bottom part is x times x minus 2. So your common denominator is going to be x times x minus 2, because that's what's over here on the left-hand side. So on the right-hand side, we end up with negative 2. The x minus 2's cancel, so I have x times 3x plus 2. Then the x's cancel, so I'm left with just x minus 2. So I have 3x squared plus 2x plus x minus 2 equals negative 2. Again, the negative 2's cancel. So I end up with 3x squared plus 3x equals 0. Factor that guy. You end up with this. So our two solutions is x equal to 0 and x equal to -1. If we check those real quick, you can see that x equal to 0 is going to mess up when I put it in there. So I have to throw it out. But if I put in -1, you see that there's no place where it messes up. So our only solution is x equal to -1. Okay, now that's solving, using rational expressions. Let's look at another type of equation that may show up, and that is whenever we have square roots. Now we undo a square root by squaring it, but it has to be by itself to do that. So on these, what you need to do is you need to isolate the square root by itself. So when I add it to the side, I got that. So then I square it, and I get x squared equals 15 plus 2x. Then I'll get everything on the same side. That's my first step when I'm solving a quadratic. And I get x minus 3 times x plus 5. X minus 3 equals 0. X plus 5 equals 0. And I get 3 and -5. Now I need to check these answers. So let's first check the x equal to 3. Now, the problem with these is we're taking a square root, and we can't take a square root of a negative. So that's what we're checking for, is that we won't take a square root of a negative. We have 15 minus 6, which is square root of 9, which is 0. So it works. Okay, so we're going to keep this solution. Let's check the other one. We have -5 minus the square root of 15 minus 2 times -5 equal to 0. Run out of room over there, sorry. So I have -5 minus the square root of 15 plus 10 equal to 0, which is -5 minus the square root of 25, which is -5. So we have -10 equal to 0. That doesn't work. So why did 3 work and -5 not work? Well, it's because right here, it's telling us we want the negative answer. And we know that with square roots, we have the plus and minus on a square root. But with this one, it's saying take just the minus. So when we took just the minus, right here, it became -5. So it became -10, so we had 0. Or -10 equals 0, which is not true. So that's why that had to go. Okay? Now similarly, let's say I have 2x, square root of 2x plus 3 minus the square root of x plus 1 equals 1. I cannot sorry, I messed this up here. I cannot just go squaring this right away because it'll cause some issues. We have to isolate one of the square roots to square it first. So I'm going to isolate that first one. Now this one's going to get long, but it works out in the end. Now when I square that, it'll get rid of the square root. So it's going to give me 2x plus 3. Right hand side, this is kind of lengthy. It's going to have 1 plus x plus 1, square root of x plus 1 plus the square root of x plus 1 plus the square root of x plus 1 squared. So I have 2 square roots of x plus 1, and this goes away. That's not supposed to be 2, it's supposed to be 1. So I have 2x plus 3 is equal to 2 plus x plus 2 square roots of x plus 1. I'm going to combine those over to the other side. When I subtract x from 2x, I get x. When I subtract 2 from 3, I get 1. Now I can get rid of the other square root by squaring both sides. So I get x squared plus 2x plus 1 equals 4 times x plus 1. So x squared plus 2x plus 1 equals 4x plus 4. I'm running out of room here. If I subtract those over, I get x squared minus 2x minus 3 equals 0. I'm going to go to another page. It factors into x minus 3, x plus 1. There's my two answers. Now, if I go back and check them, you can look and see that I'm going to have square roots of positives on all of those. And you can check them by hand, but they both check out. So both answers we will accept. Okay, now the next type we're going to talk about is what we call quadratic type. They're not quadratics. If I can get black, that'd be great here. Okay, so here's an example of one that we would treat like a quadratic, but it's not a quadratic. You see that this term, the first term is this guy squared. And that's how a quadratic is set up. And this over here is just a constant. Okay, if we treat it the same way, can we get an answer using quadratic techniques? Well, yes, you can. Well, let's first do a substitution. Let's let u equal x squared. So u squared is x to the fourth. So that gives you u squared plus, that's minus 11u plus 24 equals 0. That guy factors u minus 8, u minus 3. So we get u is equal to 8 and u is equal to 3. But u is x squared, so we have to substitute it back in. So we get u is plus or minus 2 square roots of 2, x, and then x is plus or minus the square root of 3. There's 4 answers. Okay, one that's similar to that. This one's going to be pretty lengthy. I'm going to erase this. I'm getting too close. It's kind of getting hard to do. Okay, so I'm going to first let u equal x plus 1. When I do that, I get u to the 2/3 minus u to the 1/3 minus 2 equals 0. Now again, this term and this term are related. This one over here is this guy squared. Okay? So if I can take that into consideration, I can treat it like a quadratic. So I'm going to let, we'll come up with another letter here. We'll say v equal u to the 1/3. So v squared is u to the 2/3. So that gives me v squared minus v minus 2 equals 0. So that's going to be v minus 2, v plus 1 equals 0. So v equals 2 and v equals negative 1. But v equals u to the 1/3. Okay, and I cube that to undo that, so u equals 8 and u equals -1. But u is x plus 1, substitute again. So, subtract 1 from both sides, I get -9 and -2. There's my two answers. Okay, that will conclude this section.